Morning children. Let's have the conservation of energy. Conservation of energy for class 9 standard, right? See, before understanding the conservation of energy, I would like to tell you the conservation of energy is the statement where it says the energy cannot be created nor be destroyed. Energy cannot be created nor be destroyed. It can only have transformation from one form to the other. This is what the statement is. You can write down clearly in your note, energy cannot be destroyed. Energy can be transformed. Energy can be transformed from one form to the other form. For example, let us take this as the basic ground level. Let us say this is your ground level, and say there is one height of h, up to which you raise one ball. Let us say there is one ball of mass m. There is one ball of mass m, and you raise the ball to the height of h, right? The mass of the ball is not changed. The mass is m only, and this mass m is now raised from this height, from 0 height to a height of h meters, right? Now you drop the ball from here. If you drop the ball from this height, the mass m is going to fall down. The mass m is going to fall down through the height of h, right? So when the mass of the object m was here at this height, there was certain potential energy here. The concept of potential energy is almost explained to you by your teacher. M G H. The potential energy is mgh, where m is the mass of the object, g is the acceleration due to gravity, and h is the height through which it is lifted off, right? So mgh is the potential energy of the body which the body was possessing, right? Now the moment you drop this ball from this height, it is going to fall down and will hit here. The ball will hit the ground. The mass m, but definitely it is going to hit the ground with a velocity, v. Here, before dropping, it was at rest, or initial velocity of this body was not existing. That was 0, right? Now initial velocity was 0, but it is going to definitely gain one final velocity v when it strikes the ground. That means it will come with a certain velocity and having the mass, so kinetic energy, it will hit with one kinetic energy, right? So the kinetic energy formula also you have studied already. The kinetic energy is half of m v square. the change in kinetic energy is of course half mv square minus half mu square, but u is 0, so I am not taking this into consideration, right? And you will be getting the kinetic energy as half mv square. This is the kinetic energy of the body. Now our purpose is to prove that this energy half mv square and the energy mgh should be equal to each other, because as per the statement of conservation of energy, there is no loss in the initial or the final amount of energy. Energy cannot be created. Energy cannot be created nor be destroyed. Energy cannot be created nor be destroyed. It can only have transform from one form to the other. So energy cannot be created nor be destroyed. It can only have transformation from one form to the other, right? This is how you need to support the statement also, and you need to prove also that mgh, the energy which is possessed here at the top, is purely potential, and the energy which is possessed here is kinetic in nature. Here the mechanical energy, if you need to understand what is the mechanical energy here at the top, right? At the top, the mechanical energy is the potential energy plus kinetic energy. But as initial velocity was 0, the kinetic energy is 0. So it was only possessing the potential energy. At the bottom, what is there? The potential energy here as mgh, height is on the ground level or it is 0. So potential energy here is not considered or it is 0, and the kinetic energy is existing. The kinetic energy is existing. That means the mechanical energy is sum total, no doubt, the sum total of potential energy plus kinetic energy. So potential energy plus kinetic energy, but here it is purely potential in nature and here it is purely kinetic in nature. Now suppose by any means we can prove that this amount of mechanical energy is equal to this amount of mechanical energy, then your purpose is solved. That is, the conservation of energy for your standard can be proved, right? So shall I write this one? Now to understand this one more clearly, let us take halfway after a distance of x. Suppose the mass m is going to fall, up to a certain height of, let us say, x, and here the potential energy of the body will be definitely existing as it is on a particular height. The potential energy will also be existing, and as it is falling down under the action of gravity, there will be kinetic energy also. There will be kinetic energy also. So at this point it is very crucial to understand, at this point the body is possessing the potential energy as well as kinetic energy, right? Now how much is the potential energy here and how much is the kinetic energy here, or what is the sum total of energy here, right? Let us try to understand. What is the distance of this I took? X. So how much will be this distance? If h was the height up to the top level, then h minus x will be the height here. H minus x will be the height of this. So this height is h minus x. So how much is the potential energy of the ball here? mg h minus x. So at this point the potential energy will be how much? mg h minus x, because height is from the ground to this point. So mg h minus x. And how much is the potential kinetic energy at this point? How much is the kinetic energy at this point? When it is falling from zero initial velocity to a height of x. To a height of x. How much will be the kinetic energy? Half m, the velocity at this point square. But how much is the velocity of this point when it is falling through a height of x? Like mv square is the kinetic energy formula, half mv square is the kinetic energy formula. So half m, how much is the velocity at this point is to be considered. Like the velocity u plus gt. The velocity is u plus gt. Initial velocity is 0. So 0 plus g. Acceleration due to gravity is acting here. So g into the time required. Right? But time is not given here. So this formula we are not going to use. This formula we are not going to use. Then second equation, h equals ut plus half at square. Here also time is considered, so we are not going to use. Then the third equation, v square minus u square is 2as. This is going to solve your purpose. V square is nothing but, as u is 0, 2 times of acceleration due to gravity into s. S is now x. Am I right? So this is how, considering the three equations of motions, one after the other, you will be getting the usefulness of this equation as v square is 2gx. So half m v square, in place of v square I will be writing 2g into x. Got it? Clear? So kinetic energy is half m 2gx. In place of v square I am writing 2gx. So sum total energy, that is the mechanical energy is equal to how much? Mechanical energy is equal to how much? mgh minus mgx minus plus half m2gx. 2 and 2 you can cancel out and you will be getting mgx. See here, how much is there? mgx cancels out and you get mgh. That means the mechanical energy here is equal to mgh. Mechanical energy is mgh. Now how much was the mechanical energy here at the topmost? Mgh, right? And here the ground level, how much is the mechanical energy? Potential energy is 0 plus kinetic energy is half m v square. But in place of v square, what can I write here is 2g. Now the body has covered the full height h. I am writing 2gh. So half mv square or 0 plus half m 2gh. That means here we will be getting the mechanical energy is 2 and 2 cancels out and mgh. See, so what happened here finally is the mechanical energy here is mgh. The mechanical energy here is also mgh. And the mechanical energy here is also mgh. That means clearly the energy here was whatever is same here and is same here. That means energy is not created, not destroyed. The sum total energy in the system is conserved. And this is the easiest way of proving your conservation of energy for class 9th standard, right? So why I told you the three equations of motions one after the other is to try by heat and trial method which one will be useful for your derivations, right? The T was not given, so I discarded this. T was not given, so I discarded this. And here the third equation of motion is helpful to me, so I use this one. Am I right? And this is how you can go for the conservation of energy for class 9th standard. Okay? So if you are new to my channel, please do subscribe to my channel to get the further informations of your class 9th physics and what is going on in your academic scenario, right? And if you are the member already, then be in track, like, share and subscribe to your friends. Thank you. Good day.